I'm going to provide you with 3 different strategies for trying to solve or simplify these types of problems. And let's start with strategy number 1. This is a brute force method where you take the number and you split it up. You divide it by everything that you can. Literally every single number that you can divide this by, you do. So let's see what happens. We have 108 divided by 2, and that's 54. So we could call this 54 times 2. And because it's the square root of 108, it's the square root of 54 times 2. Because 54 times 2 is 108. So these are equivalent expressions. It's divisible by 3 as well, and so we could call this 36 times 3, or rather the square root of 36 times 3. It's divisible by 4 as well. And I think it's divisible by 6. This should be... And I also think it's divisible by 9. This should be 11, 12 times 9. Okay, so option 1, just exhaust every single possibility. Divide it by everything that you can. And then what we're looking for is perfect squares. So anything that doesn't have a perfect square, it's off the list. 54 and 2, not perfect squares. We don't want those. So there were possibilities, but it didn't work out because they're not perfect squares. 36 and 3. 36 now. That's a perfect square. So I'm going to hold on to that one. 27 and 4. 4 is a perfect square, so I'm going to hold on to that one. 18 and 6. Not perfect squares. We can cross those off the list. 12 and 9. Again, perfect square. 9. Not 12, but that's okay, as long as we find one perfect square. So we have this one gone and this one gone, but the other 3 all have perfect squares, and so are all possibilities for how we can start this problem. So which one to choose? Well, you want to choose the biggest perfect square that you can find, because, well, that means if you chose a smaller perfect square, for instance 4 or 9, that means you haven't taken out all of the perfect squares in that number. You could do more. And in math, things aren't fully simplified until you find the best answer. And so this would be the best answer to choose because it has the largest perfect square. So I'm going to consider the square root of 108. I'm going to call that the square root of 36 times 3. And if that's true, then the one rule that we really learn in this unit, or at least this part of the unit, is that if you have two numbers in the square root separated by a multiplication symbol, then you can actually separate them into 2 separate square roots, like this. So the square root of 108 is the same as the square root of 36 times 3, and that's the same as the square root of 36 times the square root of 3. And that's good because while we can't fully simplify the square root of 108 without getting a decimal, we can simplify this part of it. So we can say the square root of 36, yeah, that's 6. And then the square root of 3, what to do with that part? Well, in math, usually you simplify things as far as you can using the strategy that you choose. And then once you can't simplify something, you just leave it. So I'm just going to leave that as the square root of 3. And so this, the square root of 108, a mathematician would say that is 6 times the square root of 3. Or, if you want to speak the way a mathematician speaks, they would say that it is 6 root 3. And that's our answer. So that's going to be our simplified version of the square root of 108, but that's not the only way you could have done it. I'm going to switch colors. Strategy number 2 that should get us exactly the same answer is, well, unlike strategy number 1, where we just brute force, we divide by everything, every single number, well, I think we can be a bit more strategic about that. Here's what I mean. We could divide by 2 and we could divide by 3, but and even we saw that 3 ended up giving us our best answer, but there's no guarantee that that was going to happen. So another strategy you can do is, if you're looking for perfect squares, just divide by the perfect squares. I'm not going to divide by 2 or 3 because those are not perfect squares and they're not guaranteed to get me my best answer. So what if I just try dividing by 4? That is a perfect square, and at least it finds me part of that perfect square answer. So here's what I mean. 108. Yeah, that's divisible by 4, which is our first perfect square. And so I could call this 4 times 27. And then I could just do that again. There's nothing stopping me from breaking down numbers even further. 4 is already a perfect square, so I'm going to leave him just the way he is, but 27, that's not a perfect square, so let me see if I can break it down more. Now, it's totally possible for things to be divisible by 4 more than once, so normally I would check, 27, is that divisible by 4? It's not, though, because 27 is an odd number and 4 is an even number, and so that's never going to be divisible. But I could try dividing by 9. So 27 divided by 9, yeah, that divides evenly, that's 3. So you see how I skip a whole bunch of numbers. I skip 2 and 3, I skip 5, 6, 7, and 8. I just go with only the perfect squares. Those are the numbers that I divide by. So I could call 108 4 times 9 times 3. And that's good because 4 and 9 are both perfect squares, so check out what I can do. Just like I broke up this one into 2 different square root symbols, I can break this one up into 3 different problems. So I'm going to call this the square root of 4 times the square root of 9, that's not 9, times the square root of 3. I was getting ahead of myself. The square root of 4 is 2, the square root of 9 is 3, and the square root of 3 is the square root of 3. I just leave it like that. And so check it out. It takes us more steps to get there. Well, that's arguable since we had to start by listing every combination that we could think of for option 1. But anyways, depending on how you see it, it kind of sort of takes us more steps, but it's kind of does small steps, progressive, until we get our answer. And then our final answer, because this doesn't look like that yet, 2 times 3, that's 6. And so this is 6 root 3. So there you go, option 2. And finally, I promised there would be a third option. This is option 3, and it's very different from the other two. So let's check it out. Another way that you can do this, if I want to find the square root of 108, is, well, I can break down 108 not just into all the pairs of numbers, but into every single number that divides into 108. And this is called a tree. In fact, this type of tree is called a prime factorization tree. And so the way it works is, well, 108, that's divisible by 2, and that's 2 times 54. 54, that's divisible by 2, that's 2 times 27. This is no longer divisible by 2, but it is divisible by 3, and that's 3 times 9. And then 9, that's 3 times 3. So how do we turn this into that answer? Well, let me show you. We have a pair of 2's, and we have a pair of 3's, and then we have a leftover 3. And the trick to using this method is whenever you have a pair of numbers, you can write it outside of any type of radical, but you're not going to write 4 and you're not going to write 2 and 2, it's just one of them. So a pair of numbers here is going to match up with a 2 outside of the square root, and a pair of 3's is going to match up with a 3 outside the square root. But see how we have one more 3, this guy right here, that didn't have a partner, didn't have anything to match up with. And so this is going to be stuck inside the square root symbol. And so this is another way that we can use division to break numbers apart and then turn it into an answer. And once again, we get 6 root 3. And the trick here, the key, is that a square root, what it does is it cancels a square, right? So the reason that when I see 2 of them, I turn it into 1, 2 outside of the radical is that this is 2 times 2. This is 2 squared. and the square root cancels that square. That's why I only have 1, 2 outside of the root. This is 3 times 3. That's 3 squared. And the reason that, and again, because the square root, it cancels the square, so I only write 1 3 outside of that square root. And then this is just a 3. It doesn't have another 3 to match up with, so it's not 3 squared. There's no square to cancel with the square root. That's why it's still stuck inside the square root. So we have 3 different methods, one of which is very, very different from the other 2, which maybe you'll like. And they all get us the same answer, 6 root 3. Let's try one more with a cube root. Here we are with our last example. It's the cube root of 81, and I think we can simplify this as well, even though 81 is not on our list of perfect cubes. So we're going to try each of our strategies and simplify this and show that you get the same answer no matter what. So option 1, strategy 1, was just divide by everything that you can. Now, luckily for us, this is an odd number, so it kind of limits the amount of things that we can divide by. No even number is going to divide into 81, but 3 will. This is, let's see, 3. This is 27 times 3. I knew that. So the cube root of 81 is also the cube root of 27 times 3. The cube root of 81 is also, let's see, the cube root of 9 times 9. And you know what? I think that's all we can do. So it's only divisible by 3, 9, and 27, and we already have all of those. So luckily for us, using this strategy seems to be not so bad for this problem. But we didn't know that going in unless we were really good at division and dividing things in our head. So, you kind of choose a strategy and stick with it. Sometimes one strategy is easier, and sometimes another strategy is easier. So anyways, if we're looking for perfect cubes, because this is a cube root, well, then this one's got to be off the table. There's no way it can work because 9 and 9, those aren't perfect cubes. 27, however, is. So we're going to say that the cube root of 81, this is equal to, it's equivalent to the cube root of 27 times 3. And just like a square root, we can break it into 2 pieces. So this is the cube root of 27 times the cube root of 3, which is nice for us because we happen to know the cube root of 27. It's 3. So there's going to be all sorts of 3's on here, but each one's going to mean something different. So the cube root of 27 is 3, and we also have another 3 from the cube root symbol, and we have another 3 stuck inside the cube root symbol. So this is our answer, 3 times the cube root of 3. And so you would say it like this. If you want to sound like a pro, you'd say 3 cube root 3. So there you go. That's one way that you can simplify this. Strategy number 2 was just divide not by everything that you can, but only by the perfect cubes. So we take 81, we try to divide it by 4. Doesn't work. Not 4, because 4 is not a perfect cube. Let's try that again. We take 81, we try dividing it by 2 cubed, which is 8. It doesn't divide evenly. We take it again, try to divide by 3 cubed, which is 27. That divides evenly, and we see that we actually get the same thing. We get the cube root of 27 times 3. So nice for us. It actually gets us something that we've already done, and so we would solve it in exactly the same way. I'm going to go ahead and not solve it again because we already wrote exactly that same thing. But that's the way it works out sometimes. Sometimes using one method is easier, and sometimes they're the same, and sometimes, different methods easier. But we had one more way of solving this one, and that was to turn this into a prime factorization tree. So let's take 81, the cube root of 81, and break this up. This is not divisible by 2, but it is divisible by 3. This is 3 and 27. 27 is 3 and 9. And 9 is 3 and 3. So there we go. We have 4 3's. And you might think, well, wait a second. Isn't this a pair of 3's and a pair of 3's? And so everything paired up? But since this is a cube root, I'm not looking for pairs of 3's actually. I'm looking for a trio of 3's. And why is that? Well, because a cube root cancels a cube. So I'm looking for something cubed. I'm looking for 3 of something. So I have 3 times 3 times 3, that's 3 cubed, but that cancels with our cube root. And so that's why I get 3. So this time, not a pair of 3's, but a trio of 3's, and I only write 1 3 outside of the root. But I also have one more 3, sad and lonely, and he is stuck inside of the root. So just be aware, if you're going to use this third method, it works, and a lot of people use this. This is their preferred method, but if you're going to do it, be careful. Square roots, you're only looking for pairs of numbers, but cube roots, you're looking for trios of numbers. And those are the 3 strategies that I suggest you use for simplifying these types of problems. So I hope that was helpful. Thank you for watching, and I will see you again next time. Bye-bye.